Okay, so we also have what we call trusses. So what is a truss? A truss is a structure composed of a slender members joined together at their endpoints. The members commonly used in construction consist of wooden struts, metal bars, angles, or channels. So ang truss natin mainly a slender member. What is a slender member? If you say slender member, this is just a comparison of the length and your cross-sectional area. So meaning, your length here is greater compared to the cross-sectional area. So that is what you call slender member. We also use wood in our trusses, but most of the time we really don't use wood because our wood deteriorates easily compared to steel trusses. The joint connections are usually formed by bolting or welding at the ends of the member to a common plate called the gusset plate. So our truss members doesn't really meet in a joint. So but in our analysis, we actually assume that every members meet at a joint. But in reality, they are just joined together by a gusset plate. So have the parts of truss here. We have the base, span, knee brace, bottom cord. You have the gusset plate. You have roof, the top cord. You have the bottom cord. And lastly, is you have the purlin. So this is just the parts of our roof truss. Types of trusses. Now, ang dami kasi nilang configuration ng truss. We actually have a lot. So this is your bridge trusses, this one, and this one naman is our roof trusses. We also have the types of trusses. We have three, mainly the simple trusses, the compound trusses, and complex trusses. How can we differentiate these three? So if you say simple trusses by the word itself, simple, it actually begins with a three-member truss or yung triangle lang. Then if you connect two members and you add the joint, so that is a simple truss. So in this example, you have your triangular truss nga. So that this is the simplest truss. Then if I will add a two member here and here, then I will add a joint. You have your joint there. This is also a simple truss. So in summary, simple truss, maximum of 5 members and minimum of 3 members. That is your simple truss. Now, compound truss naman, this is just a combination of simple trusses. You have a simple truss here, then a simple truss here. All together, they form a compound truss. Also here, simple truss, all together, compound truss. Same goes here. Now, what is complex truss? If it is not simple, if it is not compound, therefore, it is a complex truss. But most commonly, we say complex truss if we have an overlapping member. So, therefore, it is a complex truss. Yeah, so that is our types of trusses. We also have the determinacy and stability of truss. Now, remember from your previous lecture, we also have this one, but in beams and frame. Our equation there is Rn 3n. Now, here in truss, we have B plus R and 2J. We actually have the same principle. Pag equal sila, statically determinate, greater than, indeterminate. Then, pag less than, it is unstable. Then, we also have the same I, which is the degree of indeterminacy or the number of redundant reactions. So, that is your I. And our equation there again, it is B plus R and 2J. So say here, you have B plus R and 2J. So how many bars? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, 19. There, 19 bars. Plus how many reactions? So you have 1, 2, and 3. 3 reaction. 2 times J, how many joints? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 joints. So you have 11. So 19 plus 3, that is 22. Then 2 times 2, 22 equal. So therefore, this one, it is statically determinate. Determinate. Okay, another is we have here, same, B plus R, then 2J. How many bars? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 plus how many reactions? So 1, 2, 3, 4. Then 2 times how many joints? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 joints. So 15 plus 4, that is 19. Then 2 times 9, that is 18. So it is greater than. So therefore, it is statically indeterminate. In what degree? So you will just subtract 19 minus 18. That is first degree. Okay, next, another B plus R, then 2J. So how many bars? 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus, how many reactions? 1, 2, 3 reactions. Then 2 times how many joints? 1, 2, 3, 4, 5, 6. We have 6. So 9 plus 3, that is 12. 2 times 6, that is also 12. Equal, therefore, this one, it is statically determinate. Okay, last example, we have B plus R, then 2J. So how many bars? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus how many reactions? 1, 2, 3 reactions. Then 2 times how many joints? 1, 2, 3, 4, 5, 6, 7, 8 reactions. So 12 plus 3, that is 15. Then 2 times 8, that is 16. So it is less than. So therefore, this one, it is unstable. Actually, by inspection, we can already say that this is unstable because it doesn't have a lateral bracing. What is the lateral brace? Term we use for a member to make our structure or truss stiffer. Say for example, here, I can place my lateral bracing here. Ayan, dito. Now, pag naglagay ako ng load here, say 10 kilonewton, our structure here is stiff kasi meron to. It prevents our structure from twisting. Now, say, in our example, wala ito. Then you have your 10 kilonewton. Most probably, our structure here will twist or it will actually go down. Ayan. So, magiging unstable siya. So, by just inspection, we can already assume the unstable trusses because it doesn't have lateral bracing. You don't need to solve for this one. But if you want to solve it, it's okay. You can do that one also. You will still arrive with the same answer. Although there are instances that our equations would become statically determinate, but in reality, it is unstable. So you also have to check that one. Same goes sa beams. Diba? We also have what we call your collapse mechanism. We also have here, which is the lateral bracing. In our trusses, we also have what we call zero force members. This one is, in our truss, we can already assume that a certain member is already equal to 0 without doing summation forces vertical, summation forces horizontal, or summation moment. So we can already say that that member is equal to 0. How? So I actually have two cases, case 1 and case 2. Now for case 1, if only two non-collinear members form a truss joint and no external load or support reaction is applied to the joint, the member must be zero force members. In a joint, dapat meron kang two non-collinear members. Now, how can I say na non-collinear siya? So, if our members doesn't form a straight line, therefore, it is non-collinear. Say, for example, this one and this one. This is my joint. So, this member and this member doesn't form a straight line. Therefore, they are non-collinear members. Okay? So, in this example, we have a joint. So, maghanap tayo ng joint that has two members. So, this joint has two members. This joint also has two members. Okay, so our requirement here is two non-collinear. So, here, this member, then this member, non-collinear, check, doesn't form a straight line. Then this one, and this one doesn't also make a straight line. So, it is non-collinear member. So, check. And another requirement is there is no external load or support reaction. So, in this joint, wala tayong load and wala din tayong reaction. So, therefore, our force member AB and force member AE are automatically equal to 0. Again, you don't need to solve for it. Automatic, you will get 0. Also here, we don't have any external loads or support reaction. So, our FBC and our FCD are also equal to 0. Now, say for example, naglagay ako ng reaction ko dito. Say hinge. Yung force member AB and AE natin would not be equal to 0 because again, there is support reaction here. Now, ang requirement natin, no external load or support reaction. How about case 2? If three members form a joint for which two members are collinear, the third member is a zero force member provided no external force or support reaction is applied to the joint. So case 2, three members. So let's find for a joint that has three members. So here, this one, you have 1, 2, 3 members. How about here? You also have three members here, 1, 2, 3. Here, apat yan. This one, apat din. Now, our requirement here is that two members are collinear. So, dalawang member should form a straight line. So, in this case, this one and this one forms a straight line. Also, this one, and this one forms a straight line. Then, provided no external force or support reaction. In this one, meron tayong external load. So, our third member here is not a zero force member. How about here? Our FD. Is it a zero force member? Yes, it is a zero force member because you don't have reactions here or external loads. So that is your zero force member. It is actually recommended for your method of analysis of trusses that you must look for zero force members first so that in your solution, it would become shorter. In your statics, you have two types of analysis of truss, which is the method of joints and the method of sections. So what is method of joints? If a truss is in equilibrium, then each of its joints must also be in equilibrium. Hence, the method of joints consists of satisfying the equilibrium condition for the forces exerted on the pin at each joint of the truss. So that is your method of joints. Now remember, what is our equations of equilibrium? We actually have three. Again, summation forces vertical, summation forces horizontal, and summation moment. Now in our method of joints, we will actually just use two, which is this one, summation forces vertical and summation forces horizontal. We can also use summation moment, but purely for reaction sa loan, yung summation moment natin. We also have assumptions in our analysis. So when applying these equations, the correct sense of an unknown member force can be determined using one of two possible methods. So again, we have two assumptions. So the first assumption here is always assume the unknown member forces acting on the joint's free body diagram to be in tension, i.e. pulling on the pin. We will assume that all members are in tension. So yung sagot natin dito, if we come up with a positive answer, therefore it is in tension. Now, pag negative yung sagot natin, it would become compression. So that is our first assumption. Now, second is the correct sense of direction of a known member can, in many cases, be determined by inspection. We can already assume kung tension ba siya or compression. Say we have this truss. Ayan. Then, simply supported there. Then, I will place a 10 kilonewton here. Ayan. Maybe here, this is in compression, compression, then this one is in tension, we are already assuming the direction of our members here. Now, if our analysis, it come up with a positive value, therefore, our assumption is correct. So, therefore, this member is really in compression kasi positive yung lumabas. Now, pag negative yung lumabas na sagot natin, it just means you have a wrong assumption of direction. Say, negative yung lumabas na sagot natin dito. So, hindi dapat siya compression. Dapat tension siya kasi negative yung sagot. So, that is the difference. Now, it is really up to you which assumption is more comfortable for you to use, either this or this. Let's have an example. Determine the force in each member of the roof truss shown. State whether the members are in tension or compression. So the first thing we have to do here is to look for zero force members. So case 1, we have a joint that has two non-collinear members. So here, yung joint A natin has two non-collinear members, but it has external load. So therefore, it is not a zero force member. Then this one, yung joint C natin forms a two non-collinear members, but you have external load. So it is not a zero force member. Then this one, three members. This one, three members. Two are collinear members. So here, yung B natin, it forms a three members, but wala tayong collinear member dito. No zero force members. So here at joint D, we have three members. You can see that AD and DC are collinear. Then at joint D, we don't have load. We also don't have reactions. Automatically, I can say that my force dB is equal to 0. So, mababawasan yung solution ko, correct? Now, after determining the zero force members, I can already solve for the reactions. Okay. So our reactions, we have your hinge here. So it is going upwards, AV, then you have AH, then you have here BV. You can already do summation forces, horizontal, 0, right, positive. AH, this one is going to the right, so positive. Then we have 10 here. Our 10 here is also going to the right, so positive. This one is equal to 0. AH is equal to negative 10 kilonewton. Now, ang negative natin dito, it is just the wrong assumption of direction. So, therefore, my AH here should be going to the left. 10 kilonewton. Then, can I already use summation forces vertical? Not yet, because pag nag-summation forces vertical kayo, you have two unknowns. So we can use summation moment instead. Say, let's have your moment at A is equal to 0, clockwise, positive. So dito tayo magmo-moment. Now, yung AH and AV, it would not rotate because it is in the point of rotation. So we have BV. BV, our moment arm here to here, it is 3. Now, what is our direction? It is going that way. So that one, it is counterclockwise. So negative. Then we have yung 10 kilonewton, that one. 10 kilonewton, our moment arm would be here to here, that is 3 meters. Then the direction, our direction is going that way, so that is clockwise. So that will come positive, equal to 0. Then, therefore, our BV here would become transpose that, cancel yung 3, you would have 10 kilonewton positive. So, therefore, yung direction natin here, it is really going upwards. Then, we can already use summation forces, vertical, 0, upward, positive. So, we have AV going upward, positive, plus BV going upward, positive is equal to 0. Wala naman na tayong vertical, but we already solve our BV as 10 kilonewton. So, ang AV natin, transpose, magiging negative 10 kilonewton. Again, yung negative natin dito, wrong assumption of direction. So, therefore, it is not going upwards, it is going downwards na 10 kilonewton. Okay? So, after our reactions, we can already do method of join. Free body diagram, we have your reaction here going downwards, 10 kilonewton. Going to the left, 10 kilonewton. Then you have here, roller 10 kilonewton. Now, where will we start? Number 1 here is you can only start at a joint that has 2 unknown members. Bakit 2 lang? Because we have 2 equations of equilibrium. Summation forces vertical, summation forces horizontal. We only have 2 equations. Now, pag nag-3 unknowns ka, 2 equation, 3 unknowns, kulang ng isang equation. It is better for you to look for a joint that has only 2 unknown members. So, in this case, pwede tayo magsimula at A kasi 2 unknown members. Pwede din tayo magsimula at C, 2 unknown members. Here, we cannot start here kasi we have 1, 2, 3 unknowns. Also here, we have 1, 2, 3 unknowns. Okay? So, let's say at joint A. So at joint A, let's draw our free body diagram. So this is our joint A. We have our reaction here, 10 kilonewton. Then we have here, 10 kilonewton. Then our member. So member natin dito, this is AB. Then we have a member here na AD. AD. Then, after this one, meron na tayong free body diagram. The next step is to do the component. So, let's define the slope triangle first. This is 3, 3. So, we can say this is 1, 1, square root of 2. So, our component here would become 1 divided by square root of 2 AD. And this one also, this would be 1 square root of 2 AD. After the components, pwede na tayo mag-summation forces, vertical and horizontal. Now, anong uunahin? Vertical or horizontal? We can start at summation forces vertical first, 0 upward positive. Why vertical? Because you see, vertical natin AD, yan lang yung unknowns. Now, pag nag-horizontal kayo, how many unknowns do you have? AD and AB. So, it is much better for you to do vertical first. So, that would be 1 divided by square root of 2, AD. Then, what else? So, you have yung negative 10 minus negative 10 because it is going downwards. So, this one is equal to 0. So our AD is equal to 14.14 kilonewton. So positive, so therefore it is in tension. Okay, so next is summation forces horizontal is equal to 0, right, positive. So we have here 10, negative 10 going to the left, then we have this one. Plus 1 over square root of 2 AD, then plus AB. So wala nang horizontal, so this would be equal to 0. But we already solved AD as equal to 14.142. Sorry, 2. AB would be equal to 9.590 times 10 raised to negative 5, or we can already say that it is equal to 0. So AD, and we also have your AB. Now, yung summary natin sa trusses, it is much better that we write it on the truss. So here, di ba, 0 na to, na-solve na natin na 0. Our AB here is 0. Then our AD. So, ang AD natin, it is positive 14.142. So, pag positive, tension, negative, compression. Next is, I can already do at joint C. So at joint C, I will place my free body diagram. I have here my 10 kilonewton. Then we have your member here, CB. Then we have this one, CD. Okay, so again, component. So this is 1 square root of 2 also. So component here, this would be 1 square root of 2 CD. Then this one is also 1 divided by square root of 2 CD. After our components, we can already do summation forces vertical or horizontal. Now in this case, mas mauuna ang summation forces horizontal, 0 right positive. Why is that? Because we only have one unknown if horizontal. Pag vertical, you have two unknowns. So summation forces horizontal, you have 1 divided by square root of 2. CD, this one is negative because it is going to the left. Then our 10 plus 10. So this is equal to 0. So, ang CD natin dito would become positive 14.142 also kilonewton. Positive siya, so tension. So, here, positive 14.142. Then, I can already do summation forces, vertical, 0, upward, positive. So, we have here negative 1 divided by square root of 2 CD, then minus CB equal to 0. Then our CD, we already solved it as positive 14.142. So our CB here would become, so it is negative 9.999, or we can say it is negative 10 kilonewton. So, negative siya, therefore, it is in compression. So, this is negative 10 compression. Okay? So, that is your method of joint. Another method of analysis is the method of section. So what is method of section? If the forces in only a few members of a truss are to be found, the method of section generally provides the most direct means of obtaining these forces. The method of section consists of passing an imaginary section through the truss, thus cutting it into two parts, provided the entire truss is in equilibrium. Each of the two parts must also be in equilibrium, and as a result, the three equations of equilibrium may be applied to either one of those two parts to determine the member forces at the cut section. We also have the same assumption. So, lahat sila tension, or you can already assume kung saan yung compression, then saan yung tension, then depende sa lalabas na sagot. So, it is much easier to use method of section compared to method of joints if we have a lot of members. Say, for example, ito, ang hinahanap natin is determine the force member in GF, CF, and CD. So, in this case, you have GF, CF, and CD. So, with a cut section, I can just cut my section here, then apply the three equations of equilibrium. Then, that's it. Na-solve ko na yung mga members ko. Now, compared naman sa method of joints, You will do method of joints here, then here, then here. So summation forces vertical, horizontal, vertical, horizontal, vertical, horizontal. So it is time consuming. So pag ganito yung problem, it is much better for you to use method of section for easier solution. But you can use method of joints, you will still arrive with the same answer, pero mas madali kasi pag gumamit ka na lang ng method of section. I will cut my section somewhere here. Ayan. But first, we have to solve for the reaction. Okay, so by looking at our truss, we can already say that our AV and our EV are equal because symmetrical yung truss natin, paghahatian lang nila yung reaction. So, 400 plus 400 plus 400 plus 400 plus 400 divided by 2. So, that would be 1,000 kilonewton. And this one is also 1,000 kilonewton. Take note, you can only do this one if your truss is symmetrical. Now, say for example, ito, naging 200 pounds. You cannot do this one kasi hindi na siya symmetrical. So, yung loads nyo dito are different from your load here. Okay? So, and that's it. So, for here, let's try considering the left side. Consider left side. First thing you have to do in method of section is to draw free body diagram. Okay, so we have our free body diagram here. Dito tayo nag-cut. Let's just extend this. So, kailangan natin yan. Ayan. So, this is our joint F. This is our joint D. There. Then, this is yung GF. This is yung CF. And our CD here, the 1,000 pounds. Then here, 400 pounds. 400 pounds. And here, 400 pounds also. Oh, this should be pounds. Also this one, pounds. So for this one, same process po. So first is the component. So where will we place our component? So this one, you have your slope triangle. So this would be GF 6, 8. So 3, 3, 4, 5. Ayan. So saan natin nilalagay yung components natin ng GF? Is it here, here, or here? We cannot place our components here because pag nag-moment tayo, we don't know the moment arm. How about here? So will I place my component here? No, not also. Because dito tayo nag-cut. So yung component natin supposedly should be after kung saan tayo nag-cut. So therefore, para alam natin yung rotation or yung moment arm natin, our component should be at the end of the joint. So here, ito yung ano natin, ito yung force natin at the end joint. So therefore, it is here. There. So ang component natin dito, meron tayo dito na 4/5 GF. And we also have going downwards na 3/5 GF. Also here, yung CF natin, our slope triangle here is also 3, 4, 5. So, saan natin nilalagay yung component niya? Nasa end joint din. So, therefore, it is also here. So, we have yung vertical component, 3/5 CF, and we have the horizontal component na 4/5 CF. Okay, so after our component, we can already use our 3 equations of equilibrium. We have summation forces vertical, summation forces horizontal, and summation moment. So what equation of equilibrium will we do first? Now, it is much better to do summation moment first. Why summation moment? Because if you do summation forces vertical or horizontal, you have too many unknowns. Pag vertical, how many unknowns? So you have CF and GF. Pag horizontal, you have CF, GF, and CD. Sorry, we still have the component of CD, which is here at the end. So, CD. So, we have how many unknowns? Pag summation forces horizontal, you have CF, GF, and CD. In your summation of moment, mas magandang hanapin mo kung saan yung joint yung may pinakamarami na forces. Now, in this case, ang pinakamarami na forces ko is yung F. So, doon ako magmo-moment. 0, clockwise positive. Bakit dyan? Because pag dito, these four forces would not rotate. So, ano lang yung mag-rotate? Yung CD. Then, the forces and the reaction. Masasolve ko na agad yung CD. CD, our moment arm here, from here to here, that is 6 meters. So, times 6, what is our rotation? Counterclockwise, so negative. Then we have, what else? Yung 400 natin, it is counterclockwise, so negative 400 times our moment arm here to here, that is 8 feet. Then here to here, that is minus 400 also, the same counterclockwise. What is our moment arm? 8 plus 8, that is 16. 400, so negative 400 times our moment arm, that is 8 plus 8 plus 8, that is 24. Then we have yung 1,000. So 1,000, our rotation here would become clockwise, so positive po. Positive 1,000 times 24. So this is equal to 0. Masosolve ko na agad yung CD, which is equal to what? Okay, so ang CD natin, it is positive 800 pounds. Yan, positive, so tensions. Okay, then afterwards, summation forces vertical or horizontal. So, dito kasi, simultaneous ang solution. So, either which, you can do summation forces vertical or horizontal. So, summation forces vertical, 0, upward positive. So, this would be positive 3 over 5 CF, then minus 3 over 5 GF, minus 400 times 3, then plus 1,000. So this is equal to 0. Then summation forces horizontal, 0, right positive. We will have positive 4 over 5 CF, then plus 4 over 5 GF, then we have yung CD, plus CD is equal to 0, but our CD is already solved na 800. So what would be our CF and our GF? So our CF is negative 333.333 pounds, and GF is negative 666.667 pounds. So negative, negative, compression, compression. So we have your CD, CF, and GF already.